Alright guys, so the last two things I want to touch on with differentiation this year are the following, alright? Curve sketching. These are the four most important things when it comes to curve sketching that we need to know. Of course we could plug it into our calculator with a set of inputs and we'd get a load of points and we could plot it that way. But quite often in higher level, because they want us to know this stuff, they'll ask us specifically for where it cuts the y-axis, where it cuts the x-axis, stationary points, and I'll talk about this point of inflection here in a minute. Okay, and show you how to get it. But that's what I want to concentrate on at the minute. Now, because it's a cubic, it's going to have three roots, which means, so where it crosses the x-axis, three roots. Remember, our steps for that are trial and error to find one of the roots. Once we know a root, we know a factor. So we'll say, for instance, that x equal to 1 was a root, then x minus 1 is a factor. I'm just reminding you of that. You don't need it for this question. And then you divide x minus 1 using the array method into this, you'd get a quadratic, you'd use the minus b formula, and you'd find the other two roots. But for the purpose of this, look, they're looking for, where does it cross the y-axis? It crosses the y-axis there, okay? So it crosses the y-axis at 0, 10. Always that number there at the end. Now, max and min stationary points, we've talked about that. dy dx is equal to 3x squared minus 6x minus 9, we let that equal to 0. Okay, we use the minus b formula and we get two values of x and we sub them back into the original equation, we get two values of y. I'm hoping that's okay for max and min stationary points. Now, point of inflection, this is new. For the point of inflection, we do this. d2y dx squared. You differentiate this a second time and we end up with 6x minus 6 and then we let that equal to 0. So this is new obviously, but all you do is differentiate it a second time and let that equal to 0. 6x is equal to 6, x is equal to 1, and I sub that 1 back into the original equation and I get my y value for the point of inflection. Now, to show you what that actually looks like, or what I want to just explain it to you there a second. Okay, before I go on to the last thing. When I'm talking about curve sketching, I know that that's a cubic, right? It crosses the y-axis at 0, 10. I know it's max and it's min now, so I have an idea, all right, where it's going. And I'm not too sure what the max and the min are in that case, but we'll say, for instance, they're, we'll say here and here. Okay. Then my graph will go something like this. Okay. It's only a sketch, remember, so I don't need the roots in this case. Now, I do want to make something clear. What the point of inflection means, see the way that's our max and that's our min. Our point of inflection is going to be exactly halfway between the max and the min. So it's going to be there. Okay, that's what it's going to find us. So that's what the point of inflection actually is. But for the purpose of this, they're only looking for a curve sketch. So that will do me. Obviously, from the sketch, I'll have a rough idea of what the roots are. Okay, but they didn't ask me to do that there. So that's what curve sketching is. Just watch out for the question. Now, the last thing I want to touch on is applying differentiation. So obviously, we've talked about finding max and min, but that's applied to everything. And how differentiation is a formula for a rate of change. Okay, we've discussed that a lot. But the one thing I want to remember here, or want you to remember here, is a function can represent a real life situation. For instance, a ball. H is equal to minus 2t squared minus 3t minus 6. So you throw a ball up into the air, it's like a quadratic, an N-shaped curve. And this is a formula for height if I know the time. So this will be height and this will be time. Obviously, as time goes on, the ball is going to go up and then it's going to come down. But if the question asks us for velocity, speed, they're all a rate of change. So in this case, I would differentiate this and I'd get minus 4t minus 3. Now, what I've got there is a formula for the velocity or the speed of the ball relating to this question. So obviously, if I know the time, I can find the speed at that time. If it asks us for acceleration, this is like the point of inflection. You differentiate it a second time. If it ever asks us for acceleration, we differentiate it a second time. In this case, if I differentiate minus 4t minus 3, I get minus 4, which means my acceleration is constant, which means it's not changing, which means it's going to stay at minus 4 the whole way through it. So just watch out for that whole idea of velocity and acceleration and applying it to a real life question. So curve sketching and applying differentiation, I'll give you the questions to have a look at for the next couple of days.